Hello, my name is Nora, and for the past 4 years I've been on the hunt for regularities. Together with my supervisors, Joke Torbijns, Berthe Smet, and Lieven Verschaffel, I've been investigating children's early patterning competencies. Throughout this video, I will give you an overview of the PhD project I've been working on. The video consists of three main parts. I start with the general background of the project, and then I present the different studies that were conducted. The presentation ends with an overview of the findings and some conclusions. Let's start with a theoretical background. In this PhD project, I investigated young children's early mathematical competencies. Prior research has shown that mathematical competencies in early childhood are an important predictor of later academic success and are also associated with socioeconomic status in adulthood. So far, most of this research has been focusing on numerical competencies. These competencies include children's knowledge of different representations of numbers, such as dots, fingers, or Arabic number symbols, but also being able to compare quantities and many other skills. Although these numerical competencies have been proven to be important predictors of later mathematical performance, more and more researchers have criticized this focus on numerical competencies only. Indeed, the mathematical world of young children is much richer. Think about children's knowledge of shapes or their ability to measure the length of an object. Another aspect of mathematics is children's knowledge about patterns. Even though mathematics has been described as a science of patterns for decades, researchers have only recently started to look into young children's patterning abilities. And this is where my PhD project comes in. I investigated 4 to 6-year-olds' early patterning competencies. While there are a lot of patterns and regularities in mathematics, early patterning mostly refers to children's performance on a range of activities with regular arrangements of elements in the environment. These arrangements are called patterns. There are different types of patterns, and early childhood researchers mainly make a distinction between three types: repeating patterns, growing patterns, and spatial structure patterns. Whereas repeating and growing patterns are sequences that can be continued endlessly, spatial structure patterns are invariant organizations of elements in a 2- or 3-dimensional space. The latter pattern type is thus very different from the other two, which is why spatial structure patterns were not included in this PhD project. Repeating and growing patterns are predictable because they have an underlying rule or structure that defines how they continue. Repeating patterns have a unit that repeats. This idea of equal units that repeat forms the basis for several mathematical topics, such as multiplication as a repeated addition, fractions as part-whole relations, and measurement. Growing patterns increase or decrease systematically according to a certain rule. Growing patterns are often used to introduce functions and algebraic thinking. While these growing patterns with Arabic number symbols may be too difficult for preschoolers, there are also growing patterns without number symbols. In this growing pattern, there is each time one more red square. Preschoolers can already identify this systematic increase and, as such, take their first steps into algebraic thinking. However, little is known about preschoolers' performance on activities with growing patterns. Investigating performance with growing patterns in preschool was the first gap that we wanted to address in this PhD project. Prior research either focused on repeating patterning ability in preschool or on growing patterns and functions in primary or secondary education. Little was known about the association between repeating and growing patterning ability. A second gap in the research on patterning was the lack of attention for children's disposition towards patterns. By disposition, we refer to children's spontaneous interest in or attention for patterns. In contrast, children's patterning ability refers to their performance on tasks in which they are explicitly guided towards patterns. Prior research has shown differences in children's spontaneous interests in mathematical elements in the environment. Children might focus on several things in their environment. Consider the following preschool situation. Some children might primarily be interested in the letters on the floor or in the book the teacher is reading. Others might immediately notice the numbers in the puzzle or the pattern in the abacus. Children who spontaneously look for patterns in their environment or apply patterns to elements in their environment might also show better patterning or even mathematical ability. For example, when children look for patterns when observing the hundreds grid, they might notice that every row starts with the same 10 and that every column has the same unit. When having to count the number of objects, applying a structure might help you as well. Although searching for patterns in the environment is considered to be an important mathematical behavior, no study so far has explicitly investigated this. A third topic that has received only little research attention is the association between patterning and numerical ability. Patterning and numerical ability are two aspects of early mathematical ability that have been shown to be predictors of later mathematical performance. However, little is known about the association between these two predictors of later mathematical performance. Such research is necessary to increase our understanding of children's mathematical development and to inform early educational practices. So far, so good. By now you have an idea about the theoretical background against which my PhD project was set up. It is time for me to tell you about the different studies that we conducted in order to address the three gaps that we identified. The current PhD project started with a literature review in which I gave an overview of the research on early patterning competencies. This review provided the necessary insights to design the empirical studies. There were 4 empirical studies, and all 4 were conducted between the spring of 2017 and the spring of 2019. The first 3 studies were conducted with a sample of about 400 children that were followed longitudinally from the end of second year of kindergarten, when they were about 4 years old, until the end of first grade, when they were 6 years old. Every spring, we assessed their patterning competencies and their numerical ability. We created a new set of tasks to measure children's disposition towards patterns and their patterning ability. To identify whether there were individual differences in young children's patterning disposition, or as we called it, spontaneous focusing on patterns, or SFOP, we developed the tower task. Children received a set of 15 blocks in 3 colors, and they were asked to create a tower with these blocks. Importantly, this was the first task that was administered, and there was no reference to patterns or mathematics given before the creation of the tower. Children who spontaneously created at least 2 full units and the start of a third one were considered to have created a repeating pattern. Other creations were considered to be random. There was also a group of children who sorted all blocks on color. This was considered as a different group, given that they did not create a pattern, but they did apply some structure to the elements. To measure children's patterning ability, we developed a measure with 2 pattern types, repeating and growing patterns, and 3 patterning activities, extending, translating, and identifying the structure. This led to a measure with 6 different tasks. I will show you an example for each task. In the extending repeating patterns task, children were shown a pattern and they were asked to identify the next element in the repeating pattern. They received 4 possible answers to select from. A similar setup was used for extending growing patterns, but here children had to select a complete unit that correctly continued a pattern. In the translating repeating patterns task, children were shown a model pattern and they received small cards with colored shapes that were different from the model pattern. They were asked to create the same pattern with the colored shapes they received. A correct solution would be the following. Again, a similar setup was used for growing patterns. The third activity required children to remember the pattern and to copy it from memory. Children were shown a model pattern for a couple of seconds and were then asked to create the exact same model with cards that were provided. The idea behind this task is that children would have to identify the structure of the pattern in order to be able to correctly memorize the pattern. In this case, the structure of the repeating pattern is a repetition of a red square and a blue triangle. In case of growing patterns, children would have to see that there is a regular increase, in this case in the number of red squares, and remember the start of the growing pattern in order to be able to correctly memorize it. The first 3 studies evaluated children's patterning competencies and the association with numerical ability either cross-sectionally or longitudinally. The fourth and final empirical study explored the impact of an intervention with repeating and growing patterns. This study was conducted with a new sample of 73 children who received patterning instruction in third year of kindergarten. We compared their performance before and after the intervention with some children of the longitudinal sample who received the regular activities of the preschool curriculum and were 1 year older. The teachers were trained to give the patterning lessons themselves. In the classroom, they received the help of Mr. Pattern. Mr. Pattern learned the children all about repeating and growing patterns. Let me show you some of the materials we developed for the 20 lessons. Mr. Pattern explained the structure of both repeating and growing patterns by means of short rhymes that were presented in a pattern book. The children had to sort patterns from random sequences when there was a monster that had shuffled some of the patterns into random sequences. Children also learned to name the patterns with letters. Once they understood this, they also understood how the machine of Mr. Pattern worked. It created patterns with the same name, such as in this case an AB pattern, but with new materials. The children also learned about growing patterns and the rule that explained their systematic increase or decrease. The children and their teachers had a lot of fun during all these kinds of activities. I hope that by now I convinced you of all the hard work I've been doing over the past 4 years. However, I realize that you are probably still wondering, what have we learned from all this? Let's have a look at the findings and conclusions of my PhD project. Remember the 3 gaps that we aim to address in the current project. The first gap concerned the lack of knowledge on young children's growing patterning performance. We found that young children already show some understanding of growing patterns and that this can be stimulated from early on. Concerning the association between repeating and growing patterning ability, we found a bidirectional association between age 4 and 5. Understanding one pattern type at age 4 thus led to better understanding of the other pattern type 1 year later. Between age 5 and 6, this association became unidirectional. Repeating patterning at age 5 predicted growing patterning ability at age 6, but not vice versa. This association might reflect an ability to deconstruct a pattern into meaningful units. The second gap was the exclusive focus on children's ability regarding patterns, thereby ignoring their disposition towards patterns. We were able to identify SFOP and patterning ability as two related but distinguishable components of patterning competence. Children who spontaneously created a pattern had better patterning and numerical ability than children who made a random construction. This shows that not only well-developed patterning ability, but also spontaneously looking for or creating patterns is associated with better numerical ability. The third gap related to the association between patterning and numerical ability. Repeating and growing patterning ability were both uniquely related to numerical ability. This suggests that it is not a general detection of structure or regularities that explains the association between patterning and numerical ability, but rather the specific structure of repeating and growing patterns specifically. In the longitudinal study, we were able to explore the direction of this association. From age 4 to 5, we found bidirectional associations between the two patterning measures and numerical ability. Performance on patterning thus supported performance on numerical ability 1 year later, and vice versa. This association changed from age 5 to 6. Patterning was still related to numerical ability 1 year later, but the reverse was no longer true. One explanation for this could be that mainly basic numerical skills support later patterning ability, but not more complex numerical skills. However, it is important to note that we could not find an effect on numerical ability in our intervention study. So patterning is related to later numerical ability, but we were not able to establish a causal association. Future research should further investigate the underlying mechanisms that could explain the association between patterning and numerical ability. These findings also have implications for educational practices. Overall, the results of my PhD project suggest that more attention can and should be given to patterning in early childhood. For example, some children spontaneously create patterns, but teachers are not always aware of this, or they do not know how to react to this. In addition, patterning activities are not very common in preschool. Teachers should be aware of the wide range of patterning activities and types of patterns that exist and that are feasible for young children. The patterning activities that were used in this project to assess and stimulate children's patterning competencies could provide useful guidelines for teachers and curriculum developers. With this advice in mind, I would like to end my presentation and to thank you for your interest in my research. Unfortunately, we cannot celebrate this moment together, but I am pretty sure that next time when you will go to a party and you notice that there is a pattern in a party flex, you will reflect on your disposition towards patterns and think of me and my hunt for regularities.